This lecture is based on rate law. Now, as in previous lecture, we have seen what is actually chemical kinetics. So, rate law is basically an expression which is used to express the relationship between the reaction rate and concentration. Now, there are two terms that are being used: reaction rate and concentration. Now, to show concentration, we do have square brackets. The molecule inside the square brackets is termed as that these square brackets are showing its concentration. So, basically, the concentration of reactants is directly proportional rate of reaction. Or we can also state it as R is directly proportional to the concentration of that reactants. Let me brief it by an diagram. Just suppose that this is a diagram. You can see here there are reactants, there are products, two terms. That means these reactants produce these products. Now what does I mean to say? I meant to say that these products means the concentration of these products are directly proportional to the rate of reaction. As rate of reaction increases, that means the concentration also increases, the number of molecules increases, all the things that are used in the reaction increases. As you can see here, it is termed that R is equal to K and then concentration of 2. Now here they haven't given the proportionality sign, but we know that first let me just remove it. Okay, now just suppose that this is directly proportional, and when we'll remove the proportionality sign, we'll add is equal to K. Now this K is basically rate constant, rate constant. Now rate constant is different for different molecules. Like it is not permanent that this is the value of the rate constant and you have to follow this value. No, every reaction have different rate constant, as they have different concentration, different rate of reaction. So rate constant is variable. Now let me just remove it, proportionality sign. Now you're gonna have a look at this. This is what? This is the rate reaction equation. Now here the R is rate, K is K constant, rate constant, and these are the concentrations. Now let's read out these. Well, what are they saying? A, B, C, D are concentration of A, B, C, D. A, B, C, D are the stoichiometric coefficient. Now let me give you an example. Just suppose that we do have NH3. Now the concentration of NH3 is directly proportional to what? To the rate of reaction. That means if we have to find the concentration, so basically we are going to take the coefficients or the concentration. Just suppose that this NH3 is what? It is the product. So if we have to find the concentration of the reactants, we're going to have N and then H3. Now what are these? These are the reactants. So basically it is saying that these N, H and NH3 are what? Are the stoichiometric coefficients. Stoichiometric coefficients. And X, Y are the order of the A and B. Order of the A and B, now these basically means the moles. If we got 2 mole, so the order of the reaction is what? 2 mole. If we have the 3, the order of reaction is 3. That depends on the order mole. If we have to find the rate of reaction, this is the equation of the rate law. And if we have to find the K, so it is the formula to find K. And that's all about today's lecture. Bye bye.